Hello, Matthews Gatos here. Welcome to Chapter 7, Lesson 5, which is part 2 of the adding and subtracting video we did in lesson number 4. So what we're going to look at in this lesson is how do we add fractions that have a different monomial or binomial denominator. So we're going to expand upon that idea of a common denominator. So let's look at something like this. If I have 2x plus 1 over x minus 5, and I want to subtract x minus 4 over x plus 1, I can't do that right now because the denominators are not the same. So to write the common denominator of those two rational expressions, we need to have one of each factor. So I need an x minus 5 and I need an x minus 1. So the lowest common denominator is going to be one of each. It'll be x minus 5 and x plus 1. And I want you guys to keep this in factored form. So don't distribute it out, leave it in factored form, because remember, in the very last step, I want you to simplify, and if it's in factored form, it's easier to simplify. So let's look at this question here that's partially completed. So we want to subtract these two here. So we've already established that x minus 5, x plus 1, x minus 5, x plus 1 is the lowest common denominator. So when you look at these two here to see what we're missing a factor of x plus 1. So we multiply numerator and denominator by x plus 1. And then we are going to distribute it in group-like terms to get this quadratic. Over here, I'm missing a factor. I have x plus 1. I'm missing a factor of x minus 5. So I multiply numerator and denominator by x minus 5, expand group-like terms, and I end up with that quadratic. Now these are subtracted, so remember when we're subtracting we use brackets to show we're subtracting it term by term. So I'm going to have 2x squared plus 3x plus 1, take away x squared, take away a negative 9x, which is a plus 9x, and take away a 20. So all I have left to do is just to group my like terms. So 2x squared take away an x squared, 3x plus 9x, and 1 take away 20. So in lowest terms, I get x squared plus 12x minus 19 over my common denominator. Now, if I could factor that further, I would, but that would be as far as I can go. Okay, let's try this one here. So looking at the denominator, I have 2x and x minus 4. So a monomial and a binomial. So my lowest common denominator is going to be one of each factor. So your multiple has to include one of each so that I can multiply to this lowest common denominator. Okay, in my first fraction, to go from 2x to this, I'm missing an x minus 4, so I will multiply numerator and denominator by x minus 4. So now the denominators match, so I'm going to have x times x, x squared, x times negative 4, negative 4x, negative 9 times x, and negative 9 times negative 4, positive 36. So all I have to do is combine my middle terms there. Okay, in this one here, I'm missing a factor of 2x, so I will multiply numerator and denominator, to be fair, by 2x, and I end up with 6x squared. So now we can add them together and we'll look at our restrictions. So monomial restriction of 0, binomial restriction of opposite number. So you can see here I combined my like terms to get negative 13x, and now I'm ready to add. So I'm going to combine them as one fraction by just adding everything together. So x squared minus 13x plus 36 plus 6x squared. So add my x squareds together, and I have 7x squared minus 13x plus 36. And that would be my final answer with the restriction that x can't be 0 or 4. Again, you can always check in the calculator by putting the original question into Y1, your answer into Y2. The check always happens in the table. Notice we have some errors for our non-permissible value, but Y1 equals Y2 for all the permissible, which means values that are allowed. Okay, let's look at this one here. So I have a denominator of 2y plus 5 and a denominator of y minus 3. So lowest common multiple is going to be one of each factor. So a 2y plus 5 and a y minus 3. So that will be my denominator for each of the fractions. Okay, so I just look at the denominator. So 2y plus 5, I'm missing a factor of y minus 3. So to make it equivalent, I would multiply by y minus 3. And to be fair, I multiply the numerator by y minus 3 as well. Apply the distributive property to get your new numerator. Okay, over here, I'm missing a factor of 2y plus 5. So I will multiply numerator and denominator by 2y plus 5 to be fair. And I'm just left with 1 times itself is itself. Okay, now that the denominator is the same, I am ready to add. So my restrictions, the opposite of a plus 5, negative 5, opposite of multiply by 2, divide by 2, and the opposite of a minus 3 is a plus 3. Okay, so now that the denominators are the same, I can keep the denominators, and because I'm subtracting, I put brackets around my entire numerator of fraction 2. And now I'm ready to subtract. So I have 4y take away 12, and then I will take away a 2y and take away a 5. 4y take away 2y is 2y, and negative 12 and negative 5, negative 17. And that will be my final answer. Okay, really important at the end to factor your denominators before you or after you're done adding and subtracting, because you want it in lowest terms. So if I look back at this one here, there was nothing in common, but sometimes we're going to have a common factor. That's why it's super important to go back and factor, because we want fractions in lowest terms. So let's try this one here. Now, I didn't just use a p squared minus 1 and a p plus 1 as my lowest common denominator. I factored first. So if possible, you want to factor so that we are using the lowest common denominator. So I need a p minus 1 and a p plus 1, and that covers both of them. So this one stays the same. This one is missing a p minus 1, so you multiply top and bottom by p minus 1. Just apply the distributive property. So you have 4 over the denominator plus 2p minus 2 over the common denominator. So what I'm going to do is combine that as one big fraction, and then just 4 take away 2 is 2. So I have 2 plus 2p. And then I notice I have a common factor of 2 that I can do. So divide everything by 2 and I get 2 times 1 plus p. And then I notice that the 1 plus p and the p plus 1 are common factors. So in lowest terms, it's just 2 over p minus 1. And then you have your restrictions stated up here. I just wanted to make sure. Okay, and that would be your final answer. So this is a perfect example of why you have to factor so that you can put it into lowest terms. Okay, so final answer, always look for common factors, and your answer always needs to be in simplest form, and factored form is simplest form. Okay, let's try this one here. So 5x plus 5 and 2x plus 2. You could use each of those individually, but your answers are going to get really big. So if you can factor your denominator, always factor your denominator. So I see that I have a greatest common factor here. So I want to find the lowest common multiple of 5 and 2, which is 10. And I need a factor of x plus 1. And that will cover the lowest common multiple of both denominators. In other words, there's a number I can multiply both denominators by to get to this number here. So 5 times x plus 1 to 10 times x plus 1, I just need to multiply by 2. And to be fair, I need to do that to my numerator as well. From here to here, I need to multiply by 5. And to be fair, I will multiply this by 5, which is 15. So there is my lowest common denominator, and I'm going to add 8 and 15. I have a non-permissible value of -1, so x cannot equal to -1. So now that the denominator is the same, I write it as one big fraction just by adding the numerators. And then my final answer is 23 over 10 times x plus 1. Okay, for this one here, looking at my denominators, x squared plus 2x can be factored. It has a GCF of x. So factoring that out, I'm left with x plus 2. So lowest common multiple, I need a factor of an x, and I need a factor of an x plus 2, and that will cover everything. So this will be my denominator for each one. Now the second fraction already has that as a denominator, so it stays the same in the numerator as well. For the first fraction, I'm missing a factor of x plus 2, so I will multiply numerator and denominator by x plus 2. And now I'm ready to add. So I have non-permissible values of 0 and negative 2, so x can't be 0, x can't be negative 2. And now that the denominator is the same, I'm ready to add. So I'm going to keep my denominator the same. Oh, I'm subtracting, not adding, my mistake. And subtract the numerators. So x plus 2 take away 1. Well, 2 take away 1 is 1. So my final fraction will be x plus 1 over x times x plus 2. Nothing to simplify further. Okay, and then let's look at this last question. So a student was asked to simplify this expression and indicate the non-permissible values. Complete the student's work, which has been started below. Okay, so first step here, we factor the denominators. Now, it looks like these are different, but remember back to my simplifying trick, same but opposite. Those, in fact, are the same factor. They're just opposites. So I'm going to keep my first fraction the same because x minus 3 is great. But I'm going to factor out a negative 1 from here. So it's going to be 3 divided by negative 1 is negative 3. Negative x divided by negative 1 is positive x. And just flipping it around, it becomes x minus 3. So factoring out the negative 1, 4 times negative 1 is negative 4. Now, what we can do is, because I have a negative, remember it always goes up to the numerator. I bring it up. So instead of adding a negative, I can say that I am just subtracting. So subtracting is the same as adding a negative number. So bring the negative up, and now I'm subtracting. So now my denominators are the same. I can combine them together. Oh, actually, they're not the same. I lied. I have a 3 and a 4. Almost the same. So lowest common denominator is going to be the lowest common multiple of 3 and 4, which is 12, and a factor of x minus 3. So to change it to a lowest common denominator of 12 times x minus 3, you can see from 3 I have to multiply it by 4. So I multiply top and bottom by 4. For this one here, to go from 4 to 12, I have to multiply by 3. So numerator and denominator by 3. So multiplying those together, I have 4 times 2x is 8x. 3 times x, 3x, 3 times 5, 15, all over common denominator of 12 times x minus 3. So then I'm going to subtract my entire numerator, so 8x take away 3x, and then take away 15 is a negative 15. Okay, so once I've done that, I'm going to go through and combine my like terms. So I have 5x minus 15, but I notice I have a common factor in the numerator of 5. So let's take that out. And now you can see I have common factor that I'm simplifying. So my final answer is 5 over 12. So you can always look for those tricks where the denominator is same but opposite. If you don't notice it, you can use one of each. Your numerator will just be a little bit bigger. So to summarize my lesson, the lowest common multiple will always be, for binomials and monomials together, one of each factor. If the factor has an exponent, lowest common multiple will be the highest exponent. Okay, that last trick that we saw, if you can, factor a negative 1 if the leading coefficient is negative, so that you can actually have the lowest common multiple. And then factor the numerator and denominator of the final answer to look for common factors. You want to leave everything in factored form. So this lesson all about adding and subtracting. My little joke for you today also about adding. So half with a shovel says to the other half with a shovel, hey, let's make one whole. Because they have shovels, and 1 plus 1 is 1, which is a whole. Little double entendre there. Whole and whole. Okay, so you guys can go ahead and do your practice questions, 1 to 8 in your workbook. I hope this video helped, and I look forward to seeing you for the next one.